Hey kiddos, so this is your first homework video. Welcome. So what is this video on? This is video 1.3 and it is on y-intercept. It's going to help you with the next class that we see you. All right, so let's give a little summary before we get to the new stuff. What have we learned so far? So slope is the constant rate of change. We find it by doing the change in y over the change in x. It tells us how much the linear function goes up or down by. And we do this by adding or subtracting. We see here in this diagram, we have plus 3, that's my change in x, and plus 2, that's my change in y, which gives us a slope of 2 over 3. When we talk about the linear equation, which we'll get to in the next lesson, it represents the letter m. So slope is that m. In context, keywords to look for are each and per. We see in this example here, the slope is 3 and it represents the cost per hour. There's that keyword. So now what's new? What's new is the b value. So in that equation, y equals mx plus b, m was the slope and b is the y-intercept. So let's take a look at what it looks like on a graph and on a table. On a graph, it's the point where the line hits the y-axis. So the y-axis is the one that goes up and down right here. So the point hidden under this circle is 2. So that means my b, or my y-intercept, is 2. On a table, I can't see that y-axis. So how do I see that? It's always the point when x is equal to 0. So I see a 0 here. That means this y value is my y-intercept. So in this case, it is -1. So let's try these examples. All right, what is my y-intercept for A? So let's check it out. Here's my y-axis. Here's the point that crosses the y-axis. So my y-intercept is 2. On my table, remember it's where that point is equal to 0 with my x value. So that means my y-intercept is this one. So my y-intercept is -1. And lastly, for C, again, I have my y-axis right here. So this is my coordinate. What number is that? We count 1, 2, 3. So my y-intercept is 3. It is that easy. All right, let's move it along. I want you to try. What is the y-intercept of table A? Okay, what you should have got was that the y-intercept is, in fact, 9. What about B? Find the y-intercept. All right, if you guessed correctly, the y-intercept is right here, and that's -1. All right, last one for you to try. From this table, what is the y-intercept? The y-intercept is -8. Again, because here's the 0, so this is the number I'm focusing on. All right, so let's move on to context. This is just a little preview to help you. If you don't understand it at the end of this video, don't worry, we're going to cover it in class again. The y-intercept does not repeat. So our slope did repeat. This one does not. It only happens once. In context, keywords to look for are initial, fee, and starting value. So let's take a look from a table. So the table shows Petra's earnings for the number of hours she does yard work. Right? Here's my earnings. What is the y-intercept of the table? You got this one. You tell me. You're right. It is 0 because of this coordinate right here. All right, so what does it represent? Just like we did for slope, we identify our x-axis is hours, and our y-axis is earnings. Or in this case, we're talking about dollars. So here's what we say. The y-intercept is 0, and it represents, we use that keyword. The keyword I always like to stick with is this one. It's initial. You can change it up, but I like to keep it simple. The y-intercept is 0, and it represents the initial. And let me just say what the y-axis is, earnings. So initially, teacher earned $0. Let's try it from the graph. The graph represents the height in meters of a hot air balloon minutes after its descent. That just means going down. What is the y-intercept of the table? Should say graph, but let's ignore that. So here's my y-axis right here. So I look here and I see where it crosses, and that is 80. But what does that 80 represent? So let's look at our axis. I see time, so x is minutes. And my y-axis is height, and it has m, so that is meters. So the y-intercept is 80, and it represents the initial, let's actually say height in meters. So let's put that whole thing. So we should actually write that here. My bad. Height in meters. Time in minutes. Okay, I'll go over that again. So the y-intercept is 80. I got that from this number. That's right here. And it represents the initial keyword, height in meters, my y-axis, and I get that from right here. All right, let's give it a go one more time before we close this out. Tommy is on a strict diet to prepare for baseball season. The table below shows his progression of his weight loss. Here we go. What is the y-intercept of the table? All right, you're an expert at this. You should have gotten 225. All right, what does our y-intercept represent? Let's first go over our axis. Our x-axis is time in days. And our y-axis is weight in LBS, just means pounds. Let's put it all together. The y-intercept is blank, and it represents blank blank. That's right, it's 225, and it represents the initial weight in pounds. All right, last one. The linear function, y equals 3x plus 4, is shown on the graph. Models the temperature rise after the sun comes up. What is the y-intercept of the table? So we look, it crosses the y-axis, and it is 4. What does the y-intercept represent? All right, so I didn't write this here, but our x-axis is what? Hours after sunrise. Our y-axis is what? The temperature in degrees Celsius. So the y-intercept is 4, and it represents the initial temperature in degrees Celsius. Where did I get that? Right from here. All right, at the end of these videos, if you have any questions, now is the time to type them in so that when we get to class, the next time we see you, we can help you and make sure to answer those. All right, have a great day. I'll see you soon.